All right, so I'm going to get started just so that we can honor the time that we have. I'm going to go ahead and go over numbers one. Well, I'm going to go over the whole thing, but I'm saying I wanted to focus on a couple of things just to make sure everybody's following along so far with what we are doing. So I'm going to go over numbers 1 and 2 really quick, and then we'll get to the rest. So for number 1, I'm going to use the area model. Here it goes. So I write my first factor right here, y and -2. The second one goes on top, y plus 1. And then from there, I multiply that times these two. So we got y times y is y squared, y times 1 is 1y. Okay. From there, I got -2 times these two again. So we got -2y. And -2 times 1 is -2. From there, we combine like terms. I start with this one. I bring it down, y squared. Combine the y's. -2y plus 1, that's -1y. And bring down the -2. All right, from there, we go to this one. Remember, first thing we check to see if there's additional subtraction. There is, so I don't need to multiply. That means I just combine x squared and -7x. That's -6x squared. -5x and +6x, that's +1x. And then +6 and -9, that's -3. All right, show me your fingers who got that. Or with your hands, my bad. Yeah, we got that. Okay. Let's go to numbers 3 and 4. So for numbers 3 and 4, let me make some space. Oh, sorry. Numbers 3 and 4. There it is. This is what we did for home plate. So first thing you check, the processes are as follows. Standard form, yes. Step 2, GCF, there is none. Number 3, we do the factoring using this tool. What goes on top? The last term. What goes on the bottom? The middle term. So then what are my factors for 26? 1 times 26, 2 times 13, and that's it. Which one of those pairs adds or subtract to give me 11, 2, and 13? Okay. However, the product, this one is a negative. That means one of the two has to be negative. Well, how do I know which one, Mr. Q? Well, if you look at this number down here, the sign of this number is the sign of the biggest of the two. What's the biggest of the two? 13. What sign is this one? Positive. 13 is positive. That means our negative is our 2. All right, so I bring this down, x squared. From there, I replace 11x with these two factors. Instead of writing 11x, I write -2x, positive 13x. Then I bring down my last term. And now I do the last portion, which is grouping. That's what we call factoring by grouping. And I do it again. What is GCF for these two? X. We're left with x minus 2 plus. What is GCF for these two? Well, 13 divides both terms, so we're left with x minus 2. So what's the same here and here? Oh, the x minus 2. Yeah, that one and that. And what's left over? The x plus 13. And these are my factors.
Mr. Q.
Yes.
If we skip those two processes, would that be wrong? Would you mark it wrong?
Yes. Yeah, right now I don't want any shortcuts because we're going to get into other stuff that requires these processes. And specifically, they're going to ask us to do factoring by grouping. That's why I've been including this portion ever since you were in 8th grade. I don't know if you guys remember, I really hammer this home by leaving you 8 pages of factoring using grouping. So Yeah, so so for those of you that don't see it, like the shortcut is just going straight from here to writing our factors, but that's not what I want. I want the process because we need this process for what's coming. Okay, so you should have gotten a plus 3 and a minus 15 for the second trinomial. Yes? Yes, Mr. Q? All right, good. All right, and last but not least, number 5. It says, take the square root or cube root, and we're only going with prime roots. What does that mean? Only the positive number. So, can we take the square root of 49? What does that mean? That a number times itself. Square, if I have a square, that means I only need 2 dimensions, the height and the base. So that's 2. What number times itself? 2 times gives me 49. That number is 7. That is correct. Next, one number times itself gives us 27. Nope, there is none. So that means probably that it might be a cube. So I look up, instead of writing a square root, I'm going to do a cube root by putting an index of 3 right here. Does everybody see it? Yeah. So what does that mean, Mr. Q? What number times itself 3 times give us 27?
3.
3. And why is it called a cube root? Because it comes from a cube. Height, width, length. How many dimensions? 3. 1, 2, and 3. One number times itself 3 times give us that number 27. If it was in here, it's 3 times 3 times 3, and there it is. Woo, let's go. Is it coming back? Yeah? You guys remember these? We covered these sometime back. All right. So with that said, copy the agenda for today. Warm-up number 12, factoring polynomials. And today we're going to focus on trinomials. Make sure you get a Cornell note ready. And your home plate is 7 problems only. See how that works? When you say only, it seems like very little. Session code for Nearpod, HIEYK. Asynchronous code for Nearpod is HIEYK. And once again, what do we do with that, Mr. Q? You go there and you can get the home play from there, whether it's a play sheet, but today I'm going to actually give you 7 problems. And number 2, you need to take a picture of the slides that have the toolbar from your notes, that they look just like that, the slide that I included as write it or draw it, okay? All right, so get your home play out from last weekend, which is factoring play sheet numbers 2 to 24 evens, and go to Canvas. Turn that in right now, please. I'll give you some time. For tonight, it's only 7 problems. And number 1 reads 10x squared plus 34x plus 12. Number 2, 8x squared plus 20x minus 48. Number 3, 6x squared minus 23x plus 7. 23, Michael Jordan. Number 4, negative 4x squared plus 11x plus 20. Number 5, negative 6x squared plus 14x minus 9. Number 6, 8x squared plus 27x plus 9. And number 7, 10x squared plus 35x plus 15. And for all of those, it says to factor. Factor. All right. I'm going to move forward. You're like, Mr. Q, I haven't finished. I know. You're going to go to your synchronous session and finish copying whatever you couldn't copy, yeah? Yes, Mr. Q, we love these. All right, good. All right. So our objective, don't copy this, but we're still on factoring polynomials. Is that correct? I can factor polynomials. Okay. But today, specifically, I'm going to change the objective because we're going to focus now a little bit more on trinomials. That's why our objective for today, I can factor quadratic trinomials. I can factor quadratic trinomials. However, what are we doing? We're looking at some that have leading coefficients greater than 1. So copy everything except the blue. So I can factor quadratic trinomials. And then open up a fair model, please, for quadratic trinomials. By now, we should know what they are since we did classification of polynomials 2 weeks ago. However, I'm going to bring it back just to refresh your memory, and then we're going to move on. All right, quadratic trinomials. What are they? Quadratic trinomials are expressions. Let me repeat that again. Quadratic trinomials are what? Expressions. What do they have in particular? They have 3 terms and highest degree is 2. Okay. Examples. X squared plus 3x plus 2 and x squared plus 8x plus 7. Non-examples. X squared, 2 equals 2x. X squared plus 3x plus 2 equals 0. And negative 3 plus x equals 10. Copy those. All right, so according to the definition, if I go here, it says expressions of 3 terms, highest degree 2. Let's see. Do we have expressions here? Yeah, 1 expression, 2 expressions. Do they have 3 terms? 1, 2, 3, 1, 2, 3. Yes. Highest degree 2, 2, 1, 0, 2, 1, 0. Yeah, highest degree 2. Okay. These are non-examples. X squared, 2 equals 2x. X squared plus 3x plus 2 equals 0, and negative 3 plus x equals 10. Question, why are these not quadratic trinomials? Exactly, so write that in your critical attributes. Hashtag what? What makes quadratic trinomials quadratic trinomials? Hashtag what, hashtag what, hashtag what? All right, so you should have written something like this, guys. Hashtag expressions only, hashtag 3 terms, hashtag highest degree 2. Who got something like that? Somebody wrote maybe no equal signs or whatever the case. It's pretty much the same as expressions only. Okay. All right. So we've been working with these kind of quadratic trinomials, which is x squared plus something x plus a constant. However, now we're moving on to this. Ax squared plus bx plus c. What's the difference from one to the other? The only difference is what? The leading coefficient. This one has an a. This one did not have an a. What does that mean, Mr. Q? That now we're going to have a number in the first term, whereas before it didn't have a number on the first term. It just had x squared. So stay focused, all right? But before we move on, let's do some practice from what we did before. Look up to the screen, write your utensils down. So I want to clarify in regards to where we're at before we move on. This is where we're at. Look up, please. If I have 3 times 4, we know that is 12. And we did that with binomials. But then from there we did addition, subtraction, multiplication, and then we got into factoring. And I asked the question, if I give you the number 12, what are the factors of 12? Well, what number can divide 12? 3. 3 how many times? 4. So that means 3 times 4 are my factors. That's what we've been doing. So what are we saying? That factoring is division. Yes. Okay. How does that look with polynomials? X plus 2, x plus 3. Okay. Do we know how to multiply that? Yes, Mr. Q. I'm going to show you with the area model. X plus 2. X plus 3, x squared plus 3x. This one times these 2 plus 2x plus 6. Combine like terms, I end up with x squared plus these 2 is 5x plus this is 6. Yes. Once we did multiplication, which I already did here, this is multiplication. What did we do next? Division. What did we do for division? This. Remember that? Yeah. This one goes on top. This one goes on the bottom. Factors of 6 that add up to 5. 2 times 3 is 6. 2 plus 3 is 5. And at the end, we end up with our factors x plus 2, x plus 3, using the grouping process. You guys remember that? Yes, and so on and so forth. Okay. All right, so today I want to bring back this area model. And let's say I gave you x squared, and then I got positive, let's see, 3x, positive 1x, and positive 3. All right. And I asked you, find me the factors of that. Okay. So basically, we're just going backwards using the area model since you guys love geometry. Here it goes. How do I do this, Mr. Q? We'll start with this square. If this is a square, we have x squared. What two numbers multiply give me x squared? X times x. Okay. So x times what gives me 3x? Positive 3. X times what gives me 1x? Positive 1. So my factors are x plus 1, x plus 3. Does that make sense? Yeah? Okay. All right. So since you were paying attention, copy that area model and find me the factors, please. All right. Let's move on. So copy this one, example 1. Factor 2x squared plus 12x plus 10, and check your answer. So we're going to do that one together. We're going to go pretty fast since you already did all the practice for home play. And today we're checking for processes to see if you got the process down. Let's see. If we're checking our processes, help me with what is the first thing we check for? Ivan. First thing we check for.
Standard form.
Standard form. Thank you. How about the second thing?
GCF.
GCF. How about the third thing?
Factor.
Factor. And that's where we use the Power Ranger. What is the fourth and last thing we do, Ivan? Help him out, Roman. What is the last thing we do?
Is it grouping?
That is correct. Group. And that's what we call factor by grouping. Yeah, that's why you guys aren't skipping any steps. You're doing all the work. Yeah. Okay. Just checking. All right. So let's follow the process. Let's do this one together and make sure we got it. Step 1, is it in standard form? 2, 1, 0. Yes. Step 2, GCF. What is the GCF for all these three terms? Everyone, show me with fingers. Yes, 2. So we factor out the 2. That's our GCF. So we're done with step 1. Step 2, let's rewrite this. 2x squared divided by 2 is x squared. 12x divided by 2, that's 6x. And 10 divided by 2, that's 5. Okay. Let's go to step 3. Step 3, we factor. What goes on top? On top, we have the 5. What goes on the bottom? The middle term always goes on the bottom, 6. And guys, eventually you're not going to use this tool, but for right now, we're using it because our little niece organization. So what two numbers multiply give me 5? And when you add those same numbers, give us 6. Yeah, 1 and 5. Okay, so we're going to rewrite this. I bring down the first term, x squared. The middle term, instead of bringing this down, I'm going to replace it with these two numbers that I came up with. Instead of 6, I'm going to write 1x and 5x. At the end, I bring down the last term from this trinomial. Oh, 5, sorry. There it is. And what is our last step? We group to factor by grouping. And what does that mean, Mr. Q? That we need to check again GCF for each of the groups. So what is our GCF for these two? X, and we're left with x squared divided by x is x. 1x divided by 1x is 1. Plus, what is the GCF for these two? Or what number divides both terms? 5. We're left with x plus 1. And last but not least, what is the same here and here? Oh, these two are the same, so x plus 1. What is left over if we factored out the x plus 1? Well, 1 and positive 5, x plus 5. And since we extracted, look up, the GCF at the beginning, we are going to bring it down. So now we have our factors. What are our factors? This one, that one, and that one. Why are they called factors? Because they are multiplying. Okay. Now let me clarify in regards to the check. To the check, we do the inverse. By the way, we factored, right? This is division. So what is the opposite of division? Multiplication, which means I need to multiply these to see if I end up with the same thing I started. So I'm going to start with these two. X plus 1, x plus 5. Okay, I'm not going to do the whole process. You know how to multiply, but at the end we end up with x squared plus 6x plus 5 for these two, yes? Okay, am I done? No. What was the GCF over here? 2. So at the end I need to multiply this times 2. So distribute, that gives me 2x squared plus 12x plus 10. Did we end up with what we started? Yes, check. Now, the reason I'm bringing this back, guys, because I was going through some of the home play with multiplication, and look up. Some of you did this. Look up, look up, look up. You had something like this, 2x plus 1, x plus 5. And some of you did this. Look up. You distribute, but then you distribute to this one also. Can we do that? No, we cannot. We can only do that if this was addition. However, if this was part of this without the parentheses and addition, we can. But since we have multiplication here, the process of distributing starts or stops with whatever's next to it, just that. And then you multiply times the other binomial. So be careful not to distribute to the whole thing. Do 2 at a time and then distribute the third piece at the end for the whole. All right, so this was review. The only thing, if you notice, we added the GCF. Okay, let's see how you do with one by yourself. Y'all ready? Yeah, here we go. Example 2. You don't have to copy the verbatim, but copy example 2, negative 3x squared minus 9x minus 6. Factor that, please. I'll give you some time. Ready? Go. First things first, standard form. Yes, it's in standard form. Second thing, GCF. Some of you just wrote 3. However, what did I say on the other sessions? That whenever the leading coefficient has a negative, included as your GCF. So like that, you won't get stuck. So let's see. Parentheses. Negative 3x squared divided by negative 3, that's positive x squared. Negative 3x divided by negative 3, that's positive 3x. And negative 6 divided by negative 3, that's positive 2. All right. Step 3, factor. All right, what goes on top? The last term, which is 2. What goes on the bottom? The middle term, which is 3. And what are our factors of 2 that add up to 3 if you add them? 1 times 2 is 2. 1 plus 2 is 3. Okay. Now that we found them, let's rewrite this. X squared. Instead of writing 3x, what are we going to write, everyone? Yeah, we write positive 1x, positive 2x. Bring down this last term. And what is our last step? Factor by grouping. We group 2 and 2. GCF x, we're left with x plus 1 GCF here, it's divided by 2, x plus 1. So what's the same here and here? Oh, x plus 1. And what's left over, Mr. Q? Oh, x plus 2. However, since now we had a GCF at the beginning, we bring that down. So that's -3, and these are my factors. Hands, if you got that? Okay, good. Yeah, you should have gotten this. The only thing we saw was the GCF. I know some of you made a mistake because you didn't include the negative here, and all of a sudden you ended up with something weird at the end. Okay. All right. So let's crank it up about 5 notches. Yeah. Let's go. Let's go. Example number 5. Copy this one. It says factor 6x squared plus 11x plus 4 and check your answer. Just copy it. Look up to the screen. All right. So the process, once again, step 1. I'm gonna write it right here just so we can have it. Standard form, okay. Step 2, GCF. Step 3, factor, which we use that. And step 4, grouping or factor by grouping. Okay. So is it in standard form? Let's see. This is to the 2nd degree. This is to the 1st degree. This is 0 degree. Yes, standard form. Is there a GCF? Can we divide by a number other than 1 all the way through? No. Is there a variable on each of the terms? No. So we're done with number 1 and number 2. However, the next one, before we do this, it's going to be a little bit different. Look up. Hopefully you saw that this one has a number as a leading coefficient, which makes it different from the other one. So what do we do with that, Mr. Q? Now we take that, multiply that times the constant, and that goes on top. The middle term will always remain the same. That goes down here. So once again, where did we get this top number? Not the last term, because now there's a leading coefficient. We multiply the first times the last to get that one. So pairs of factors of 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which one of those adds or subtract to give us 11? 3 and 8. Copy that really quick. All right, so what do we do from there? We're done with standard form GCS. We're in the process of factoring, which means we bring this down, 6x squared. Instead of 11x, what do I write, guys? Yeah, these. Replace that. We write 3x plus 8x. And then you bring down the last term. What is our last term? Plus 4. And we're done with the last process, which is what? Grouping. So what number divides each term? 3. Do both of them have at least an x? Yes. Okay, so 6x squared divided by 3x, that's 2x plus 3x divided by 3x is 1. Bring down the little plus sign. One number divides each term, 4. 8x divided by 4 is 2x. 4 divided by 4 is 1. So what's the same here and here? 2x plus 1. Yep. And what's left over? Yes. We got 3x plus 4. And these are my factors. You're like, Mr. Q, this is a piece of cake. So what's the only thing that changed from the week until right now? That now we have a leading coefficient. We need to multiply times the constant. And then the rest is the same, pretty much. Okay? All right, I'm going to give you one for you to do by yourself. Let's see how you do. Example number 6. Example 6. 6x squared plus 11x plus 3. I'm leaving it almost exactly the same so you can follow the process. See if you get that by yourself. Go. Factor 6x squared plus 11x plus 3. I'll give you some time. All right.
It's okay to end up with not just 1x, right?
Yeah, that's right. So let's see, example number 6. Step 1, was it in standard form? Yes. Step 2, was there a GCF other than 1? No. Step 3, factor. What goes on top? Hopefully you saw that it has a leading coefficient. You multiply that, that's 18. And what's the middle term? The middle term is 11. All right, factors of 18. Factors of 18 are 1 times 18, 2 times 9, 3 times 6. Which one of those pairs adds or subtract to give us 11? Yeah, 2 and 9. We rewrite the first term. We rewrite the second term, but the second term, instead of writing 11, becomes what? 2x plus 9x. Then you bring down the last term here. And the last step is to factor by group. Group, GCF here is 2x. We're left with 3x plus 1. GCF here is 3, and we're left with 3x plus 1. So what's the same here and here? Oh, the same there and there is 3x plus 1. And what's left over? 2x plus 3. These are my factors. For those of you that wrote 9 and 2 at the beginning, then these are flipped, right? 2x plus 3 and 3x plus 1. Okay. Show me your fingers how come you are with these. 4, 5, 4, 5. Yeah, yeah.
I'm still confused. How did you get 3x plus 1 and then 2x plus 3?
3x plus 1. Okay, so the question is,
Yeah.
what is the same here and here? What looks the same? 3x plus 1, is that correct? So those, that becomes one factor. So we bring it down and only write it once. What's left over?
Oh, okay.
What's left over? The 2x and the 3x. That's why we write it like that.
Oh, okay. I get it now.
All right.
Thank you.
All right. Thank you. And how do we check, guys? We just do what? Multiply, whichever way, area model or distributed property. I'm not going to do that. You know how to do that by yourself. And let's go to the last one. Last one.
Well, homework, are we supposed to check them?
We don't have homework.
I mean, the whole plate.
Oh, if it says to check, check. But I don't think it's going to say. All right. And let's crank it up a notch. Let's go to this one. Example number 9. Number 9. Negative 4x squared, negative 34x, and negative 42. Negative 4x squared, negative 34x minus 42. Negative 4x squared minus 34x minus 42. All right, let's see. Our process. Kenny, what's our first step?
Standard form.
Thank you, standard. Is it in standard form, guys? Let's see, 2, 1, 0. Yep. Step 2 should be what? GCF. Question, is there a number that divides all terms? Yeah, show me with your fingers what number that is. Deuce, yes, that's a deuce. However, if the first term has a negative, then our GCF is what? -2. Make sure you extract with that. So, negative 4x squared divided by -2 is 2x squared. Negative 34x divided by -2, that's positive 17. Negative 42 divided by -2, that's positive 21. And we go to step 3, which is factor, which is our little device that we use to do.
Mr. Q,
Yeah.
isn't it 17x?
Oh, yeah, I did that to see if you were paying attention. 17x. All right. So remember, if it has a leading coefficient, you multiply that, that's 42. Okay. 17 goes down here. What two numbers factored give us 42? 1 times 42, 2 times 21, 3 times 14, 4 times nothing, 5 times nothing, 6 times 7. Which pairs of number add up, subtract to give us 17? 3 and 14. Let's rewrite this. 2x squared. Instead of 17, what are we going to write, guys? Yeah, these right here. So that becomes positive 3x, positive 14x. Then we bring down the last term. Let's group, which is our fourth step. Group or factor by grouping. What does that mean? Again, we need to ask what is the GCF for each group. What is GCF for right here, Ivan?
It's X.
And we're left with 2x plus 3. How about here?
7.
7. And we're left with 2x plus 3. So, Alejandro, what's the same here and here?
The factors 2x plus 3.
2x plus 3, that is correct. And what's left over?
And x plus 7.
X plus 7, thank you. However, guys, what did we take out at the beginning? -2. These are my factors. Do you know how to check? Yeah, by multiplying, yeah? Let's go. Show me your fingers so I come to you with these. Yeah, 5 4s, 5 5 5, yeah. Okay. So that's pretty much it, guys. That's going to be the home play. Okay. And once again, make sure you have your color pens because, like I said, we're going to continue adding more processes to this. You need to have your organization, especially those that are struggling with this. Okay. So let me show you really quick your home play once more. Here it goes. Oh, your asynchronous code HIEYK. That's where you get your home play from. And your home play should be 7 problems. These 7 problems. Okay. Once again, if you need to revisit the lesson, go to YouTube. I'll try and upload this by the end of today, like around 3 o'clock, 3:30ish. Sometimes it takes a little bit more for me to edit. But other than that, it should be up there, okay? And also with your in synchronous code, you should go and be able to check out the home plate by yourself, all right? That's our lesson for today, guys. Once again, nice seeing you guys. Keep up the good work. And if you need to attend tutoring, I'll see you guys after lunch. Peace.